Good morning and welcome to the demonstration of LogScope LogAnalysis. Firstly, we're going to start LogScope, and this is done by pressing the icon in the menu and it pulls up the LogScope main screen. In the screen you have Project and you have Import. The icon up here allows you to log in, and I'm logged in, and you can check on your active subscriptions which are listed here. So the first thing we're going to do is we're going to load a data set. We're going to use the demo example.las. So this loads the data set, and it loads it as a standard plot. So we'll just go down to the bottom of the plot. We're going to set the scale to 2000, and we can see the whole section, and it's reported in feet. So we'll change this to meters. So the log analysis is accessed from the menu, which is accessed by right mouse click or swiping down from the top. So from this menu, I'm going to open up a template that's called the log analysis interpretation. Okay, so we have the plot there. We'll change the scale to 2000 so that we can see all the curves. Now, the log analysis is accessed by pressing log analysis. We have divided the log analysis into logical processes, and these can be switched on and off by just clicking on the button, and it will highlight in red when a process is not being used, and also when it doesn't have logs. When you switch off something like that, the logs that are missing are RT, LA, RXO, LA, and you will have to fill them in. So let's see if we've got an RT. So we don't. So let's go back to the processes. Let's switch that on, and it will do the resistivity first, gamma ray correction, density correction, bad hole flag, then it'll do V-clay computation, which is done from the minimum of neutron density and gamma ray, or either of those two measurements, apparent porosity, lithology, RWA, porosity, total and effective, and saturation and permeability. You can do these processes in one at a time, or you can actually do them all at once. We're going to do them all at once. We've checked that the input logs are there, and LogScope will identify as many of these input logs as it can. And then we go to the parameters, and we only have currently one zone, and we can determine eccentricity of the tool for the gamma ray size, casing thickness, and correct if the gamma ray is running casing, or we can correct for KCL. And then we have the logging company, which is Schlumberger, but you can choose any of the logging companies. So we'll just leave that as Schlumberger. The FTC type is at LDT. There's also FTC available. And then you've got the parameters for the gamma ray V-clay, clean, and clay. The density row matrix and row clay, which is also used for V-clay. N-phi matrix and clay. And the N-phi 2.2, which is used for the matrix line. And then you've got the density matrix, the sonic matrix, sonic fluid, and the sonic compaction factor, which we'll leave at 1. And then you've got the fluid density, which is 1. And then you've got the dry density for dry clay. And then you've got the UMTA, ρMTA parameters here. And on this crossplot, you can actually switch off the lithology. So if the PF is barite affected or whatever, but you still want to use the information, you can actually switch off the lithologies that you wish and recalculate. When we come down to the saturation, we've got A, M, which are 1 and 2 respectively, and N is 2, and the SW equation is Archie. I prefer to use Indonesia, so we use Indonesia. The neutron tool is the, we're going to use the SLB CNL, and then we've got these other parameters here. So if we hit process, on the plot, all the grading curves will get filled in. So let's give it a go. Let's see what happens. So all the curves are filled in, and if you notice, we've got some lithology changes here, probably casing. Here is another lithology change, and here is the top of the reservoir. So we can actually put in zones. So let's switch on show zones and edit. So if we click on here, we're going to call this base of casing. We're going to call this one top of seal. We're going to call this one of reservoir, and then we've got the bottom. We may want to go in, so we'll change the scale to 1:500. And change the position of the top of the reservoir. So we just click on that and we can move that up or down. So I may want to move that just up a little bit, or maybe even up to here, above these two little sands. And then with the zones we can save and exit. And then if we go back into edit, we can show the grid, and we have the formations shown here, and the parameters for each of the zones. Now, rather than change the parameters in a numerical table, we're actually going to change them by using cross-plots. So let's go to the cross-plots. So in the cross-plot, if you watch the cross-plot tutorial that we have, you'll see that you can set this cross-plot up. But we actually want to go to the LogAnalysis cross-plots, and they are located here. Okay, so this is the first one, and we've got a bunch of points up here. So if we just move that, we can see those points here. We're going to move this, and we're actually going to call this a limestone. And move that point there. If we right click, we can show the menu bar, which allows us to see the zone parameters for that. So let's move to the next zone. Again, we're going to do the same thing. And we'll move that up there. And we'll move this across like so. And then we'll move to the next one. This one we're going to call Clastic. And then this is the actual reservoir, and this is gas. So we're going to put that there. And put this point there. So we've changed for this particular cross plot. We do not have any parameters for the neutron, for the sonic neutron as yet, or the sonic density, but you can see that the sonic density has a value of around 1.3. For the compaction factor. So let's go down here and let's make the compaction factor 1.3. And let's have a look at this one. And this is 1.4. And this is 1.5. And this is 1.56. And then we process. So if we go to the next template, here we have the gamma ray versus RWA. We're going to leave that where it is. And we're going to change this one to there. There. Then we're going to go here. Put that there. We'll put this one here. And we're going to put this one here. And our RWA, our RW should be somewhere here. So if we go to the next template, here we have the SW there, and this is the picket plot. And then we'll move to the next cross plot, which is the reverse picket plot. And we'll work down through the zones. Okay, and then we're going to go to the UMTA ROMTA cross plot. And this is the reservoir. we're just going to move that up and move that across like so. And move this one like so. And like so. And like so. So when we process, let's go back to the cross plot. Let's go back to the plot. So if we look at the top of the reservoir, we've got our reservoir defined, and if we look at the tracks, we've got the row matrix calculated, and if we click on the we can actually see the values, and we can move up and down. And the matrix density for these is around 2.58, 2.65. So it's possible that we need to change this, change the density of that, and change the hydrocarbon density. So here we have the gamma ray density neutron V clay calculated, and you can see the values, and they're reasonably consistent down through the section, which is what one would expect from a neutron density and so on. One of the things one would expect. So let's go and let's change for the reservoir zone. Let's go and change the row hydrocarbon and change it to 0.2 and recompute the results. So there we go. And there we have the log analysis done. And should you want to export a plot, you can. So we're going to save the plot. The plot and the archive of this project will be put in the discussion groups that we have, and you'll be able to review that at your leisure. Thanks very much.